Hi, today I'm going to be doing a quick update video on the 3D simulator. Now this might look 2D, but it's actually kind of a 2.5D thing. And the first game I work on using this simulator is probably going to be a 2.5D game. I'm not going to be going full 3D just yet, as I have a lot of stuff to figure out when it comes to rendering. Especially because there's going to be like multiple materials, some transparent with refraction, and I might even be looking into the NVIDIA's new ray tracing stuff. But like first, just going to focus on the physics with like a 2.5D game. And yeah, one quick thing, I'm trying to build up my subscriber count again, so I guess if you like this video, just subscribe or tell some friends about it. I just want more people to know about this game when I come out with the beta. And if I reach 800 subscribers, I'm gonna just release the this demo that I'm showing off today. Alright, so first I'm gonna just kind of go through. I'm going to go from the simplest material to the more complex one. So the simplest is gases. So I basically just turn down the rest density. Shear modulus doesn't really come into play here, because shear modulus is for like shear forces, where which are more useful for like elastic materials. And you can just see some basic shock waves. I'm thinking of having the option to kind of fully simulate every single material in the game. So that includes the air, which it can have an impact on the... I think it is useful to simulate the air because you can have... Well, when I work on reactions, it'd be useful to have it actually follow the real world rules where you actually need oxygen for something to react. So yeah, just not the most exciting material. You just see some like shock waves and stuff. Or if you turn down the smoothing, it gets a bit rougher. Yeah, it's not the most. So I'm going to just turn back to rest density, and now you have some watery type thing. Can still turn up the smoothing to get a more viscous kind of liquid. Either smoothing, which is like kind of an artificial velocity smoothing thing, or shear viscosity can also, like you could also turn down the smoothing and just purely use shear viscosity. Shear viscosity is more physically based. So you have a, and then I'm just going to turn shear viscosity back down again. I usually like bulk viscosity up a bit. If you don't have it on, the particles tend to oscillate a bit around the rest density, so I like to have it, though this might sometimes smooth out some of the like shock waves or something. See, with bulk viscosity down, you can have like more shock waves propagating through the liquid, or like the shock waves don't dissipate as easily, and then bulk viscosity kind of smooths out the shock waves. So it's a little bit of a, I won't say that this is like the most accurate simulator. I've actually lowered some of the, like I've gone back to using linear interpolation for a lot of stuff instead of like quadratic or cubic interpolation. So yeah, you can turn bulk viscosity up a bit. So usually for water I like to keep bulk viscosity up and then the smoothing down so that you can get a lot of vortices and not. If you turn up the rest density to the fullest, the particles are much closer, and you'll get like more sheets and little tendrils forming. Or if you turn down the cohesion, that allows the particles to separate from each other, so you get like more of a splashy type simulation. And then going after liquids, you can also simulate viscoelastic materials. So let me just move up the shear modulus, and you'll see the materials start to kind of freeze a little bit. Actually, with cohesion down, it's more of a granular thing. So I'm going to move cohesion back up since I want to do the viscoelastics first. Let's see. So yeah, you have like kind of a little goopy thing, bounces a little bit, holds its shape with that when the forces that are applied are kind of weak. But if you apply some strong force to it, you can like kind of break it apart. And then after some time, it like kind of clumps back together again. You can also turn the rest density down a little and becomes kind of more of a softer, spongy type thing. Like maybe, let's see, sell it down here. And then lastly, yeah, when you turn down the cohesion, that allows the particles to kind of separate from each other. And so this is useful for like sand or snow or that kind of stuff. And you'll notice little hills forming. Doom. So that's that for the current update. In the next version, I'm going to also be adding back the fiber stuff from the 2D, so I'm going to be moving that over. And once we had fibers, then you have materials that can hold their structure better over time, or like with forces. And yeah. Thanks for watching.